Hello, my name is Tom Meany and I'm here today from Anarogudibaise to talk to you about a new ADC, the AD7124, which we have released onto the market with optimizations to make it easier to achieve functional safety at the system level. The ADC is a 24-bit Sigma-Delta ADC, and the rest of the presentation will explain some of the features we have added. A video such as this, it is not possible to explain all the features, and more of them are described in the datasheet. Probably the most important diagnostic that we've added is something to check the entire signal chain. And what this does is it allows you to switch in 0, plus or minus full scale, and in addition plus or minus 20 millivolts using extra channels available on the internal MUX. The idea is that if you can convert 0 and plus or minus full scale, you can be reasonably certain that your signal chain is working correctly. The addition of the plus or minus 20 millivolts gives you signals that can be converted on any one of the PGA ranges. This allows you to verify that you are on the correct PGA range. Being on the wrong PGA range could give you very, very gross errors. Looking at table A.13 of IEC 61508, these inputs equate to reference sensors and allow you to claim up to a diagnostic coverage of 99%. An unusual feature on the AD7124 is something to protect against soft errors. Soft errors are typically seen as a concern on parts with a large amount of RAM. The AD7124 doesn't include any RAM per se, but it does contain a number of flip-flops in the form of configuration, setup and calibration registers. These registers, similar to RAM, can be influenced by neutron or alpha particles and cause a bit to flip. Within the AD7124 there is a little state machine, and every 350 odd microseconds it goes around all the registers and calculates a CRC. This calculated CRC value is compared to a value from when the last update to the registers occurred. If it is found to be an error, then a status bit is set so that the user can know that one of the registers has unexpectedly changed. Another feature that I want to bring to your attention is the CRC on the SPI interface. This will be the subject of a more detailed video, so I won't go into it here, but basically it protects you against data corruption on both reads and writes to the AD7124. In addition to the diagnostics which I have outlined on the AD7124 itself and the additional features which can be seen on the AD7124 datasheet, some additional diagnostics have been added to assist in detecting hazards external to the AD7124. So for instance, burnout currents have been added, and the burnout currents can be enabled so that if the ADC inputs are floating, it will force the input voltages to go to full scale. Going to full scale is deemed to be detected. There's also an on-chip temperature sensor. Temperature is a very important cause of failure because it can lead to what is known as common cause failures. Common cause failures are an excellent way to defeat redundancy when two items, one of which is expected to be a backup or a redundant version of the first one, the temperature can cause them both to fail. So having an on-chip temperature sensor can be very handy from a functional safety point of view. Another feature I'd like to bring to your attention is that there's a mode in the part where it can detect that the regulator capacitor is either missing, too low in value, or has fallen off. A bad supply voltage is also another great cause of common mode cause failures. The reliability data for the AD7124, in common with the reliability data for all our released integrated circuits, is available on our website at the address shown on the screen. The AD7124 was developed before we put in place our 61508 compliant development process. However, the AD7124 was developed to our very high standard normal development process based on our approximate 50 years experience in developing integrated circuits. Thank you for listening to this video today from Analog Devices. For more information, see analog.com/functional safety.